Hello guys and welcome to the channel. Today I want to present a Clojure service template that I was working on recently, and the link is in the description, so if you're just interested in code, check it out. But I'll just give an walk through the code and some core ideas of it. Before we start, I just want to say that it's basically based on my preferences, and I was working on it because I need some kind of template for my own personal projects, but it still should be pretty useful for a lot of people, especially for Clojure beginners, if you want to learn how to combine libraries and see some approaches how to write web applications in Clojure. So first of all, I'm using Leiningen. I still think that developer experience of this tool is much better than Clojure CLI, and I don't see anything wrong using Leiningen, especially for a project like a web application or something like that, because there you basically get like a build out of the box. You just run lane uberjar, or if you want to run it, you just run like lane run, lane trampoline run, stuff like that. So yeah, it is a Leiningen-based template. I'm using Clojure 12, which is the recent version. And let's start. Basically, everything starts in this core namespace. And first thing that we do is we're reading the schema with Arrow library. So the first library we're using is Arrow for the configuration. The main bit is here in the resources/config EDN, and here you can see how the rendered map will look like. So these bits will be replaced by the value from the environment variable. This tag literal says that it's from env, and then for some things like port, we also cast or parse the string value from the env to a long in this case. So we have a web server. It has host port and a cookie store key for the sessions cookie encryption. This is hard coded here, which shouldn't be in prod. So change that for now, if you want to use that in production. Then database, we have a spec for that, user port, password, name, host. I think you can just use JDBC URL and change a couple places as well. So then there's example for the external HTTP call, which will be to this open free weather API. For that, I just passed the base URL. And also I added kind authentication. So it's like a managed authentication provider, similar to Auth0 and stuff like that. And they just have a nice free tier, and I really enjoyed using it in one of the projects. So yeah, that's the base of our application. Moving to core, we reading the spec right here. We're saying we getting this resource and we read the configuration, and then we calling the start system. So configuration map is passed to our build system. And you can notice this, which is I tried to use Mali in a couple of places to do a bit of types. So you can think about it as a TypeScript. So JavaScript is not typed. You have an extra layer of optional types from the TypeScript. Here, we don't need an extra language. We just use Mali, and we enable instrumentation if we want. I'll show that in a sec, but basically this means that this first vector, cat, means that it's like a sequence of arguments, and the first one should be service config. And service config is defined in this types CLJ file, and here we can see Mali schemas, so it's map, and it is closed, so that means it doesn't accept additional keys, and then we have all our components here defined, configurations for them. So let's say, for example, web server. If we go there, we also have a map, and it says it's also closed, and then we have host port that is int, and cookie store that is a vector of ints. And what that can do for me is, for example, if I enable instrumentation and I run this function and I pass something wrong here, it will have a runtime exception with a nice error message that I'm missing some value or the type is not correct. I'll demonstrate that in a second. So the other core library of the template is component. I'm not a huge fan of integrand, and I think component just works and it's fine. We have components for each of these elements in our system. So we have web server, we define that. Here we have the database, which basically is just a wrapper on top of there's a component function provided from the NextJDBC library, and we can just use that. And also this Kinder client for the authentication. Also I have this, it's not a real component, but I just use config as the top level key. In that case, I can just pass it as a dependency to the web server, and everything that uses web server will have access to config, entire config map of the application, which could be quite handy in a lot of cases. So moving on, let's quickly work through the database config. As I said, I'm not creating a component myself. I'm just using the function provided by the NextJDBC, and it works. The only thing I'm doing is you can pass an extra init function, and it's defined right here. The purpose of that is this function will be called right after the data source is created, and it will get the data source as an argument. So in that case, here, the purpose of this is to run migrations. I'm using the Flyway library, and this is basically some Java interop code that you need to run migrations. The files for that will be in the resources database migrations. So it is right here, resources database migrations, and then we have the first one. I'll create one table to store some data from our API calls for the demonstration purposes. So yeah, that's database, and also, as you can see, we have a typed function here. In core, we're passing partial config there. So now we can validate that only database component config is what we receive right here. Next one, web server. Let's go there. Again, it's typed, and this is how we started. I'm using Jetty and Ring and Rated. So Rated is the routing library running on top of Ring. Here, just run Jetty, and I'm building the application right here. So we're creating the Ring handler, Ring router. Then this is how you define the routing table. It takes a bit of time to get used to these nesting vectors, but at some point it will just make sense. This is the type of, or like the method of the HTTP call. So in this example, I just have all gets, but you can have multiple things here. So let's say post and then a different handler, stuff like that. So I'm just having the index page and some API for the authentication. They'll basically all eventually call some endpoint in the Kinder itself. And then I have the API right here for the API call that will return some JSON for us. So in the middleware, I think this is pretty standard, like you want to decode parameters, you want keyed parameters, like you can go through that middleware and see what it's doing quite easily. It's not a lot of code there. Interesting one is this wrap dependencies, which is custom one, but it's also pretty simple. So as you can see, we get the request and we add an extra key there called dependencies, and we put everything like this. Actually should be dependencies, and we passing this component. So basically, in each request that our handlers will receive, we'll have dependencies key, and that's the way to access our components in the system. I can probably show you it here. So let's say we have this login handler, then we get the request, and then if I want to get the Kinder client component, I just call this function, and it goes to request dependencies, you can see here, and then our component. That's how you access database as well, etc. So for database, I guess it will be here. So as you can see, we have request, and then this utils request to database will go to dependencies and get the database from our dependencies. Cool. So moving on, let's quickly cover index page. So this will return HTML. The way I build HTML is the Hiccup library, which I think the best one in Clojure to do the HTML things. I don't really enjoy the templating libraries where you write your plain HTML with placeholders and then render it. I just use this DSL in Clojure, which you can then convert to HTML string. So the page is pretty simple. We'll cover this user thing later, but if there is a user and we get it from request, actually it will get it from the session cookie, but we'll check that out in a sec. So if user exists, we show this div. We show welcome, some user information, and log out. If not, we provide login and sign up options. So next, this body, which is basically just a Clojure vector, is passed to layout, which is a helper function that builds the rest of the page. As you can see, we include some JavaScript, like for example Tailwind. You can immediately style your applications with Tailwind classes, and then I usually use HTMX for different purposes, so it's also included. And then just body here, and after that it is wrapped into this helper function to return HTML, but really this is just call from Hiccup library that will convert our body to HTML, and then we cast it to string. Return type in that case is text HTML, and we return status 200 by default, but you can override it here. So that's how HTML bit is working. Let's go to our handlers and to weather API. Here we have a JSON response, so you can pass just Clojure data right here, and it will be casted to encoded to JSON. I'm using this Chariot library now. It is basically really fast, and it has 0 dependencies, so you won't get your usual Jackson or something like that, faster XML dependency hell, and it just works. And it's also, I believe, the API of the library is just drop-in replacement for the data.json library. So that's for API. What we're doing here, you can just go through the code yourself, but basically just an example of external HTTP call. So when we get weather forecast data, we will build our external API, which is this function, this URL. We are getting base URL, as you can see from dependency config weather API base URL. Then it will be v1 forecast. Then we pass some query params, and we get in the response. I'm using the Babashka HTTP client. I think that's one of the best wrappers now on top of the Java net HTTP client, and it basically requires Java greater than 11. But I think that there's not much reason to use anything else than Java HTTP client wrapper. That just works. So if this is not 200, a usual error handling is we throw an exception with some information. If it is 200, we're using the Chariot again to read JSON. Then you can provide a key FN, which will apply transformations for each key in your JSON. And the library is really nice. Camel Snake Kebab. It just provides a lot of ways to cast from different casing to other casing. In our case, we just want our keys to be kebab case keyword. In the response, we'll get this hourly key, and inside that we'll have two different vectors. One is time and one is temperature for 2 minutes. And I just decided to combine that in a map, so it's easier to represent. So in our response, we'll return something else. So what we do here, we use the sorted map for the keys, because the key will be time, and then I iterate over time and temperature minutes, and for each pair I build a map entry and then put it into the map. So the result will be time, which is key, and value as a result. Here, the example how you use database. So getting this database, and then in this case, I just wanted to show transactions as well. So for each entry, we want to insert an entry in the database. But as that's a list, we want that to be atomic. So we wrap the entire block in transaction. We get in the transaction, and then we need to reassoc it back to our dependencies. So in this case, in the database, we'll actually have our transaction now. And then we do seek and pass the dependencies and insert the entry. But the entire block is atomic because it's transaction, right? At the end, we just return the JSON as I showed previously. Database queries. So I'm using the NextJDBC, as you've seen, and Honey SQL. Two helper functions for execute and execute one. It basically will just do Honey format for us, and also I'm using this predefined options. So it basically says that we'll have a snake case for all table names and column names in the database, but when we get it back, we'll have kebab case, and it will be unqualified maps. So our keywords will be something like column, not something like table name / column, which is harder to structure in some way. So for the queries itself, we have two. We have insert, which is calling this execute one. In Honey SQL, you just use Clojure data structure to define queries. So we have insert into table name, values, and it will get value entries. We also return everything back. So for the get, it is even simpler. Select all from the table name. And then you see we wrap that execute, and it will get the query. It will format it to a string right here, and it will be executed with NextJDBC. The other thing I want to show is the development flow, and it is in this dev file. I'm using the library from component, like a helper one for the component REPL, and it will provide things like reset and stop. I also have a command configured. I need to go to some Clojure namespace, go to REPL, and then you can see these commands, and I have this restart system. And if I call this, you see something happened in the REPL, and it shows OK at the end. And basically, what is going on is my command is calling this reset function. And I initialize my dev system right here. So for database, I'm using test containers. I'm just starting it here. And then I'm building the system, and I put some hard-coded config right here. The only thing that you don't see is this client secret for the kind authentication. and it is from the env vars, but you can figure it in your REPL. So basically, you go to the REPL settings and you can put env vars there. So they are not part of the source code, but you can still access them in your REPL session. So I can now run that multiple times, and it always stops the system and then restarted it. It also refreshes the namespaces and restarts the system, which is really nice for development purposes. So I wanted to show you also the validation of the schemas. So as you can see here, I'm starting Mali instrumentation with Mali dev, and it will show us nice errors. So let's demonstrate. For example, I make a mistake here intentionally. I restart it, and you see we have a message, and it says that we missing the required key port, and we have disallowed key port 1. So it's like immediate feedback that we made a mistake. So if I remove this and restart, it's normal again. I believe I forgot to show the Kinder client, right? Kinder client, you just configure it here. There's a Java SDK that I'm using. Domain client ID secret, redirect URL, logout redirect URL. Then grant type will be code, and we want OpenID, email, and profile grants, like scopes. In the handlers, it is here. We have login page, sign up page, and logout page, and a Kinder callback. So the main thing here is we basically follow this, like standard OS2 protocol. And finally, we can get user information when we get required tokens. And then we're using this session key, and we pass information here. And this is part of the wrap session ring middleware. And I'm providing the cookie store. So the cookie store, I'm using the cookie store. You provide this encryption key there. So everything you put in your session cookie will be encrypted, stored as the session in your browser, and then next time when you receive the request, it will be decoded from the session and put in your request. And in that case, that's why we can do things like utils request to user. So we get session and user, and here we'll get information of our logged in user. So let's reload that. So this is the application running. So I put my email here, and now I should receive a code. Here we go. 5859227, and I'm redirected back, and as you can see, I have some user information. If I click logout, I'm back to the original page. If you want to set up yourself, you just need to go to Kinder and generate some secrets, create a new project, etc. But I'm planning to do a full video about Kinder integration, so it will be really detailed one. And finally, I think it is the tests. So in tests, we have the test support. That's the third way how we access our system. So we can start our test system. There's a fixture for that. You see here, we do the configuration fn, build system, start system, and then we run our test, and then we stop it. Again, I'm using the Postgres test container to run it. This should be improved, but basically that's the first iteration how you write your test. Basically, you start your test container, then you start your system, and then you have access to it right here. So as you can see, I can do test support database to access my database, or I can do like real calls right here to our API. It is obviously failing, but it's failing because wrong assertion. Actually, this worked, as you can see. This endpoint returned data. And also, if I start the system, I can demonstrate that the API is working as well. A nice way of doing that is you can create a collection of endpoints in IntelliJ itself. So there's end file for localhost. I'm just using this. And if I just go here to the requests, I can call this one. And you can see we have a response right here. So cool. This is it, I guess. I'll push some changes and improvements to this template. And also, if you have something as well, you can raise the pull request. I can probably merge it if it makes sense. If you have any questions, I don't mind asking them in comments. I'll try to answer. And yeah, have a nice one. See you next video. Bye bye.